So let's move ahead with our simple u substitution. So if you recall the Leibniz notation, which is what? Dy dx, right? We can specify the definition of the differential, which is dy, right? Which is dy, and also dx as well. Therefore, we can say that, let me write here. So I can say that my dy, I can say that my dy over dx is equal to f prime. I hope you all agree with this. We have already treated it. And per this, when I want to make, if I want to make dy the subject, I can say that my dy is equal to, because I multiply through by dx, dx will cancel dx, and then at the end of the day, I'm going to get dy equal to f prime of x dx. That means we are integrating this function, or we are representing dy with respect to dx or x. So based on this, let's look at some couple of examples. This is a simple u substitution, remember, and whatever we are going to do here, it's going to help you to kind of understand whatever we are doing, right? It will help you a lot. So let's look at something here. First of all, let's find y equal to, or for y equal to f of x, which is equal to x power 3. Find dy. So solution. What we need to do is that now we have our function y equal to f of x, which is equal to x power 3, and we are being asked to find dy. So finding dy, this is a simple differentiation as we have already treated it. So in the simple differentiation, we are going to get dy over dx is equal to 3x squared. So in finding dy, we need to make dy the subject, and therefore we are going to get dy is equal to, because we multiply both sides by dx, and at the end of the day, we are going to get dy equal to 3x squared dx. So this is our answer. So let's look at the second example. The second example, let's find, or for u equal to f of x equal to x power 2 over 3. Find du. So solution. So now we know that our u is equal to x power 2 over 3, which is equal to f of x. Therefore, we can say that our du, the differential of u with respect to x, will be given to us as 2 over 3 x power 2 over 3 plus 1. Is it minus 1? Sorry, I'm doing differentiation, so let's take note of that. Minus 1, which is 2 over 3 minus 1, and therefore my du over dx is equal to 2 over 3 x power negative 1 over 3. So based on this, to make du the subject, you multiply both sides by dx. This one will cancel, the now our du is equal to 2 over 3 x power negative 1 over 3 dx. So this is our final answer. So this is kind of going to help us a lot in whatever we are going to do as time goes on. So please take time and understand these ones. So let's look at the third example. So looking at the third example, we have for our u equal to g of x, which is equal to the length of x. Find the u. And therefore we can say that if our u equal to length x, then our du with respect to dx is equal to 1 over x. And therefore, to make du the subject, we multiply both sides by dx. And therefore, we are going to get du is equal to 1 over x dx. Because I multiply both sides by dx, and this cancel this, and then at the end of the day, I'm going to get 1 over x multiplied by dx. Let's also look at the fourth example. Having y equal to f of x, which is also equal to exponent x power 2. Find dy. The same approach here. Let's look at how we are going to do that. So you can use the chain rule here to do this. But whatever you can do is that, as you learned in your calculus 1, you take the power here, you differentiate it, and you multiply by the function itself. And at the end of the day, you are going to get dy dx to be equal to the differential of x squared is what? 2x. And then the function itself is exponent x squared. And at the end of the day, you are going to get 2x exponent x squared. And then to make dy the subject, you multiply both sides by dx. And at the end of the day, you are going to get 2x exponent x squared dx. So far, the dx in the function integral of f of x dx has always played no role in integration other than to indicate the variable of integration. So what I mean is that this dx over there tells you the variable that we are integrating with respect to. So if we are integrating with respect to t, you will see the t. When we are integrating with respect to x, you will see the x. When we are integrating with respect to I, you see the I. So it depends. So now, finding an antiderivative may seem impossible, but yet if we note that now we have 2x exponent x squared. So finding an antiderivative may seem impossible, but if we know that the 2x exponent x squared is equal to x squared multiplied by 2x, then we can say that the antiderivative of the function 2x exponent x squared is equal to exponent x squared. So how can we find such antiderivative directly? So in order to do that, we need to come up with something we call u substitution, as we did earlier on. So having 2x, let's say dy equal to 2x exponent x squared dx, right? So doing this integral, we are going to have an integral of this, and therefore in doing this we need to do something called u substitution. So in this case we can say that let's u equal to x squared, which is the exponent of the power of the exponents e. So in doing that, as we did earlier on, we find the du dx of this representative, and we are going to get 2x. And remember that as soon as we say let u equal to x squared, the whole question changes to become 2x exponent u dx. That is the integral. But here we are integrating with respect to dx, but we have represented here by u. So how do we do that? In doing this, when we find the differential of this, we are going to get du over dx equal to 2x. And here we want to represent this one by u, so therefore we need to make dx the subject. And making dx the subject, we are going to get dx equal to, that we multiply both sides by dx. And then at the end of the day, we are going to get dx equal to du over 2x. So getting du over 2x, we can actually replace this one inside here. And at the end of the day, we are going to get the integral of dx, then exponent u, and then when we replace this dx, we are going to get du over dx. So you can see that there are some common terms inside, and therefore it can cancel out. So at the end of the day, we are going to have the integral of exponent u du. And as we all know, integral of exponent x is the same as the exponent x, and at the end of the day, we are going to get exponent u, right? And this is an indefinite integral, so we need to add the arbitrary constant of integration, which is c. And therefore, since we said that let u equal to x squared, we can bring it back. So our integral of 2x exponent x squared is going to give us e exponent x squared plus c. So this is actually what we did here. We differentiated and we have gotten it back. So in effect, we have used both the chain rule in reverse. Now the chain rule was in differentiation, and then the use substitution is the one that will reverse it. So we can check the results as we have done here with this differentiation. And this procedure that we did over here by representing the x by u is what we refer to as the substitution, or the simple use substitution, and some books call it change of variable. Sometimes it can involve trials and errors, but sometimes you become more proficient as you practice more questions. So if most questions, when you try the substitution and that doesn't work, or the result in an integrand that can be easily integrated, then you have to try another substitution. So while there are many integrations that cannot be carried out using this use substitution, any integral that fits any of the formula as I stated here, can work for you. Yes, can be evaluated. So let's move ahead and then look at how we will be able to apply this use substitution in solving some common examples. Thank you for watching, and see you in my next tutorial.